I'm basically Kamal Lakhani, who teaches a subject based on electronics, that is BW. Now in BW you have two major topics which cover 70% of your weightage, which is nothing but AC analysis and DC analysis. Now you all must have studied in your 12th standard about current electricity, wherein you have studied a lot about DC signals precisely. And you'll also studied EMI, which relates to AC signals. But then you'll only studied that and that was the end of the story. In engineering, you have a lot of practical applications which you have to improvise on what you study. Now, what is seen is that, let's say, I'll just give a simple example to relate to how we teach in Vidyalankar. If you analyze very carefully, the house that you all reside in, over there the electricity that you get, that electricity board that you get is basically an AC signal which comes to your house, which is 230 volts AC signal. Now, what is seen is that as technology is advancing, everything is becoming digitized in nature. So, as things are getting digitized, everything is working on artificial intelligence, which requires microcontrollers to support it. Now, for microcontrollers to work, that requires an input which is a DC signal. But despite of that, all your households, all the supplies which you get at your house is an AC signal. Now, if you analyze carefully, an AC signal is a structure. Is a signal which looks like this. It's a waveform which is an alternating signal. Continuously alternating with respect to time. Obviously, it varies with respect to theta, which is equal to omega t. Let's say if I'm taking an example of a voltage signal, V of theta. Okay? This is basically your AC signal, an alternating signal. Simultaneously, this is how my DC signal looks like. It's basically a signal, again varies with respect to time. But the only difference is that it is constant with respect to time. Let's say some value of voltage, V. Now what is seen over here is that if I have to generate a comparison between this, most of the technology that you work with requires a signal like this. But despite of that, what we get at our house is a signal like this. And if I have to give a very simple example, let's say your mobile phones. Each and every person over here that whatever mobile phones, everybody uses mobile phones, correct? And a mobile phone requires a 6 volts DC supply to charge. This is a signal which looks like this. But eventually you will connect that to a supply, a source, which is basically your charger, and eventually the charger goes to your mobile phone. So if you're looking at that charger is nothing but a circuit which converts an AC signal to a DC signal, precisely a rectifier circuit with a filter circuit. But the conversion of a signal like this to a signal which looks like this. Now what is seen is that if I have to think very practically, if I'm converting a signal like this to a signal which looks like this, obviously it's going to consume a lot of energy. Obviously the signal is not directly going to be converted, correct? So despite of so much of advancement in technology, why do you still get a signal which looks like this at your respective households? Why can't we just replace a signal like this to a signal like this? Obviously it's actually a matter of thought. The reason behind it is that if at all you look like a signal like this is a very traditional signal. Actually, if you look at the modern generation, nobody uses this signal. All the appliances actually require a signal like this. But the added advantage you get over here is that this signal is a variable signal. Now, because of this, what is seen is that since it's variable in nature, what is seen is that the charges that flow during the positive half cycle, it flows in one direction, that at a variable rate. During the reverse half cycle, the same charges are going to flow in exactly the opposite direction, again at a variable rate. Now, this signal obviously is going to have a peak value, let's say some maximum value Vm. But that value is only going to be for a fraction of a second, which is, let's say I assume to be 90 degrees according to this signal. 0 degrees, 90 degrees, pi, 2 pi. Okay? So only for a fraction you're going to get maximum value of voltage. If I have to analyze the nature of this signal, what is seen is that this voltage is constant with respect to time. The charges that are going to flow is going to be constant with respect to time. Because of which what is seen is that, let's say tomorrow, in place of having a signal like this which you get at your house, you may get a signal like this. And let's say at your house you have a small kid who somehow gets into contact with the supply. I'm sure most of you are looking at this video must have somehow got into contact with your electrical grids, right? So when that happens, what you will see is, this is a very minute observation that you must have seen, is that when you get into contact, you automatically push outwards from that particular supply. The reason being is you are actually not pushed away. There's the force which pushes you away. The reason being is that if at all I am moving, like during the positive cycle of this signal which you get at your respective houses, current is flowing in one direction, there's a force of attraction that actually pulls you towards the supply. Simultaneously, during the reverse half cycle, the current that is flowing in one direction now is going to revert and flow in exactly the opposite direction. Because of which what is seen is that rather than getting a force of attraction, that reverts, that inverts is, and that becomes a force of repulsion. That is the reason why before your mind can actually respond to such an instant, you're actually pushed away, and then eventually you realize, oh my god, what just happened? So this is the reason why this signal is one of the most safest signals. Because of which, in BW, this is considered as one of the most important topics. Undoubtedly, this signal is the most commonly used signal. But this signal again is very, very important. Imagine if at all this signal would have been in your house, what actually would have happened? Current is flowing in one direction, but you are actually directly exposed to maximum value of voltage, maximum current flowing through it, that too in one direction. Force of attraction, there is no force of repulsion. That is the reason why most of the times you all must have heard that, you all get actually stuck to the supply. The reason being is that there's a DC supply, because of which there's a force of attraction which pulls you, because of which you are not actually able to push out of the supply. So in this manner, really what we try to do is that these two signals that you see as a very simple ideology of what we actually are going to be learning in a precise manner. This carries somewhere close to 40% of the total weightage of my subject. This carries somewhere close to 30%. So there's going to be a detailed analysis we are actually going to be doing on that. So this was just a simple idea to make you understand. So what exactly does Vidyalankar precisely focus on? Anyways, I hope you all enjoyed my video. Best of luck. Take care.